Good morning, dear student. Now I am discussing the engineering mathematics of the first unit differential equation. I am previous lecture to discuss the differential equation of order and degree and related some numericals with the help of by separation variable methods. Now I am discussing the second of first order and first degree differential equation, homogeneous differential equation. What do you mean by the homogeneous differential equation? Now, I have discussed the homogeneous differential equation. You can note down. First, you can note down homogeneous, homogeneous differential equation. Homogeneous differential equation. Homogeneous differential equation is stand for a homogeneous differential equation in the term dy of dx is equal to f x comma y total upon phi x comma y is the function function f x comma y and phi x comma y and same degree. A homogeneous equation is known as if the denotes dy of dx is equal to fx comma y total upon phi x comma y have fx and phi x comma y have the same degree. If the fx comma y and phi x comma y have both function are the same degree is known as homogeneous function. In this case, to solve the differential equation, first we let y is equal to vx and dy of dx is equal to v plus x dv upon dx. V plus x dv upon dx. First, I consider in this case you can solve the differential equation with the help of this function. First we let y equal to vx and dy of dx is equal to v plus x dv upon dx. And now, therefore, you can use by the separation method. Therefore, again use the variable separation method. Use the variable separation method. This method is mostly used to solve the differential equation. This is a very important for your examination and to solve the numerical problems of differential equation. First, you can note down, for example, You can note down. To solve the differential equation, to solve the differential equation, if you can note down the numerical x minus y dy plus y square dx is equal to 0. This is a differential equation. First you can note down this is a differential equation. Now solution of the differential equation. Now we have x minus y dy plus y square dx is equal to 0. You can write x minus y dy is equal to minus y square dx. You cannot separate x and y in the place of dy and dx. So I am using this method. This is a homogeneous method. Now you can write dy of dx is equal to minus y square upon x minus y. This is the same degree of both fx comma y and phi x comma y. You can write the homogeneous differential equation. Now you can put, now this is equation number first. In equation first, let y is equal to vx, then and dy of dx is equal to v plus x dv upon dx. Now you can put the equation first, then you can put this value dy of dx is equal to v plus x dv upon dx is equal to, put the value of y, this means minus v square x square total upon x. This is a x minus y, it means x minus vx. Now you can write v plus x dv upon dx is equal to v square minus, it means 1 minus v. Now you can write x dv upon dx is equal to minus v square total upon 1 minus v minus v. Now you can solve this. X dv upon dx is equal to minus v square minus v plus v square total upon 1 minus v. Now you can write, this is a cancelable. Now you can write minus v upon 1 minus v. Now you can write x dv upon dx is equal to v upon v minus 1. Now therefore you can write v minus 1 upon v dv is equal to dx upon x. Now you can write this, you can note down this numerical. This is a very important for your examination. This is a homogeneous differential equation. First we find this is a homogeneous. If a homogeneous function, now you can solve this method. First we let y is equal to vx and dy of dx is equal to v plus x dv upon dx. Now you can put this value in the equation first. Now you can solve this type of equation. First we find this equation. Now you can note down this numerical. You can note down this. This is a homogeneous function. Now you can separate this in dv and dx. Now you can note down. First we write v minus 1 upon v dv is equal to dx upon x. Now taking integration on both sides, you can write integral 1 minus 1 upon v dv is equal to integral dx upon x. Now you integrate to this function. Integration of 1 is equal to v minus, this is the integral of log v is equal to integration of 1 upon x, this means log x. Now you can write plus c1 c. Now you can write v minus log v is equal to log x plus c. Now you can write, put the value of v, since y is equal to vx or v is equal to y by x. Now you can put this value in this equation. You can write y minus x minus log y by x is equal to log x plus c. Now you can write y by x is equal to log x plus log y by x plus c. Now you can write y by x is equal to log x into y by x. This is a log m plus n plus c. Now you can write y upon x is equal to log y plus c. Now you can write y is equal to x log y plus c x. This is a solution of differential equation, or you can write y is equal to x log y plus c1. This is a solution of differential equation. This is a solution of homogeneous differential equation. You can note down this. This is a very continue to the next numerical. You can note down. Example. To solve the differential equation, you can note down the differential equation. dy of dx is equal to y plus under root x square plus y square total upon x. This is a differential equation. Now the solution of the differential equation, we have dy of dx is equal to y plus root x square plus y square total upon x. This is a homogeneous differential equation because the denominator degree and numerator degree is the same. I know this is a homogeneous differential equation. Now the solution of this function, Therefore, let y is equal to vx and dy of dx is equal to v plus x dv upon dx. Now you can put this value in this equation. This is equation number first. Now in equation first, you can write v plus x dv upon dx is equal to vx plus under root x square plus v square x square total upon x. Now you can write v plus x dv upon dx is equal to, you have common to x, now you can write x v plus under root 1 plus v square total upon x. Now you can write v plus x dv upon dx is equal to v plus under root 1 plus v square. Now v will be cancelled. Now you can write x dv upon dx is equal to under root 1 plus v square. Now you can write the separation method by using variable separation. You can write dv upon under root 1 plus v square is equal to dx upon x. Now taking integration on both sides, you can write integral dv upon root 1 minus 1 plus v square is equal to integration dx upon x. Now the integration of 1 upon root 1 plus v square is equal to log v plus under root 1 plus v square is equal to integration of log 1 upon x is equal to log x plus log c. If the whole value of in a log, then constant is also will be log. Now you can write log v plus under root 1 plus v square is equal to log cx. Now you can write v plus under root 1 minus v 1 plus v square is equal to cx. Since y is equal to vx, or you can write v is equal to y by x. Now you can write this value. You can put this y by x plus under root 1 plus y square upon x square is equal to cx. Now you can write y plus under root x square plus y square total upon x is equal to cx. Now you can write y plus root x square plus y square is equal to cx square. This is a solution of homogeneous differential equation. If you have any problem related to this numerical, this method, please you comments to my video and like and promote to my video to the other students and your friends. This is a very important numerical related to the engineering students and other students. First we can now note down this numerical. This is important for your examination. Now you can note down this numerical. Continue to the next topic. You can note down equation reducible to the homogeneous form. If the differential equation is not in the form of homogeneous, you can reduce the homogeneous form. You can use this method. First, if you have find the homogeneous equation, what is the homogeneous equation? If the numerator degree and denominator degree will be same, this differential equation is known as homogeneous differential equation. Let the equation of the form dy of dx is equal to ax plus by plus c total upon ax plus by plus c. This is a small c and this is a capital C. Can be reduced to the homogeneous form. First you can write small x is equal to capital X plus h and small y is equal to capital Y plus k. Now you can put this value in this differential equation. You can write this is a differential. This means dy of dx is also equal to d capital Y of d capital X. You can note down. You can put this value in this equation. First you can write dy of d capital X is equal to a capital X plus h plus b capital Y plus k plus small c total upon a capital X plus h plus b capital Y plus k or plus capital C. Now you can write d capital Y upon d capital X is equal to a capital X plus b capital Y plus C plus you can write this plus a h plus b k plus c total upon you can write a capital X plus b capital Y plus a h plus b k plus c. Now putting if ah plus bk plus small c is equal to 0 and capital Ah plus capital Bk plus capital C is also equal to 0, then you can write can we write d capital Y of d capital X is equal to ax plus by plus total upon a capital X plus b capital Y. This is a homogeneous differential. I have reduced in the homogeneous form of the differential equation. You can use this method to reduce the homogeneous differential equation. If you cannot find in the homogeneous, you can use this trick, this method. First you can write small x is equal to capital X plus h and small y is equal to capital Y plus h. Therefore, small dy upon dx is equal to d capital Y upon d capital X. Now you can put these values in this equation. You can find the homogeneous differential equation. For example, continue to this topic, equation reducible to the homogeneous form. You can note down the numerical example. For example, to solve the differential equation, you can note down the differential equation dy of dx is equal to y plus x minus 2 total upon y minus x minus 4. This is a homogeneous differential equation? No, this is not a homogeneous equation. I have reduced this equation in a homogeneous equation by using the reducible theorem. First, the solution of differential equation. We have dy of dx is equal to y plus x minus 2 total upon y minus x minus 4. This is not a homogeneous equation. Now you can reduce the homogeneous differential equation. Now you can first let small x is equal to capital X plus h and small y is equal to capital Y plus k. Therefore dy upon dx is equal to d capital Y upon d capital X. Now you can put this value in the equation first. In equation first, you can put these value in equation first. Now you can write d capital Y of d capital X is equal to, you can write capital Y plus k plus x. This means capital X plus h, capital X plus h minus 2. Now you can write y. This means capital Y plus k minus capital X plus h minus 4. Now you can write d capital Y of d capital X is equal to, you can write capital Y plus capital X plus h plus k minus 2 total upon capital Y minus x plus k minus h minus 4. You can reduce this form of differential equation if small h plus k minus 2 is equal to 0, or you can write h plus k is equal to 2 and k minus h minus 4 is equal to 0, or you can write minus h plus k is equal to 4. Then you can solve this differential equation. This is cancelable. 2k is equal to 6. Now k is equal to 3, and you can put this value in this equation. This means h is equal to minus 1. H equal to minus 1. Now you can write, therefore d capital X upon d capital Y upon d capital X is equal to capital Y plus X total upon capital Y minus X. This is a homogeneous differential equation. This is a homogeneous differential equation. This is equation number 2. Since equation number 2 is homogeneous differential equation, homogeneous differential equation. Now let capital Y is equal to V capital X and d capital Y upon d capital X is equal to V plus dV upon d capital X. Now putting these value in equation second, then you can write V plus dV upon d capital X is equal to, you can write V capital X plus X total upon V minus V capital X minus X. You can write V plus 1 total upon V minus 1. Now you can write, this is X. Now you can write X. Now you can write X dV upon dx is equal to V plus 1 upon V minus 1 minus V. You can write V plus 1 minus V square plus V total upon V minus 1. Now you can write capital X dV upon d capital X is equal to, you can solve 1 minus V square plus 2V total upon V minus 1. Now you can use the variable separation method, solve this differential equation. You can note down this numerical. This is a very important for your examination. Now this is a reducible to the homogeneous differential equation. I am continue to this. Last you can find the value of h is minus 1 and k is 3. Now next equation will be find x dv upon dx d capital X is equal to 1 minus v square plus 2v upon 1 minus v minus 1. Now I am using variable separate method. Now you can find v minus 1 total upon 1 minus v square plus 2v dv is equal to d capital X upon X. This you can solve this. Now taking Now taking integration integral on both sides you can write integration v minus 1 total upon 1 minus v square plus 2v dv is equal to integral d capital X upon d capital X upon x. Now you can write this integral. First we let 1 minus v square plus 2v is equal to t. Now differentiate of this equation. You can find with respect to t 0 minus 2v plus 2 dt upon dv. Now you can write minus 2 v minus 1 dv is equal to dt. Now you can write, now putting these value in this equation, you can write integral dt upon minus 2 t is equal to integration d capital X upon x. Now you can write minus 1 by 2 log t is equal to log capital X plus log c. Now you can write this. Now you can write log t minus log t is equal to 2 log capital X into c. Now you can write log c capital X to the power 2. Now you can write log 1 upon t is equal to log c capital X to the power 2. Now you can write 1 upon t is equal to c capital X. Now you can put all the value of this since small x is equal to capital X plus h and small y is equal to capital Y plus k, and I have let capital Y is equal to v capital X and 1 minus v square plus 2v is equal to t. Now you can put these value in this equation. You can write, please, you can note down this. You can rub to this. You can find in this equation, since 1 upon t is equal to cx. Now you can write the value of t. You can write c into cx 1 minus v square plus 2v is equal to 1. Now you can write c, put the value of capital X. Capital X is equal to x minus h. Now you can write the value of v, 1 minus the value of the value of now you can write the value of v is equal to capital X upon x plus x capital X square upon capital y square upon capital X square plus 2 capital Y upon capital X is equal to 1. Now you can write C x minus the value of h is equal to minus 1. This means plus 1. Now you can write 1 minus the value of capital Y is equal to y minus, you can write the value of k is equal to 3 to the power 2 upon x small x plus 1 to the power 2 plus 2 small y minus 3 total upon x plus 1 is equal to 1. Now you can write, C x plus 1 to the power 2 minus y minus 3 to the power 2 plus 2 y minus 3 into x plus 1 to the power 1 is equal to x plus 1. This is a solution of the differential equation. This is a solution of differential equation. You can note down, this is a very important numerical for your examination by using the reducible to the homogeneous method. Now you can note down this numerical, and please like and subscribe to my channel Dual Mathematics, and promote to my channel to your other friends. Share to your other friends. If you have any problem, please comments to my videos. Thank you.